Have you ever wondered how a thick bar of ordinary steel turns into a gigantic chain hundreds of meters long? That chain is not just for use in any machine. They hold the largest cargo ships, oil tankers, and huge ocean vessels in the modern world steady. Even in the midst of a terrible storm at sea, this iron monster holds thousands of tons of ships safely. And the most surprising thing is that each link of this huge and powerful chain is made with a combination of fire, extreme pressure, science, and perfect human skill. So let's enter an incredible factory today that makes the world's strongest anchor chain, where ordinary steel gradually turns into an invisible protector of the sea. The tour begins with thick bars of strong steel. These are not ordinary pieces of iron. These are special grades of high-quality carbon steel, which can withstand years of salt water, intense sea pressure, temperature changes, and constant friction. Each steel bar is verified through lab tests before it reaches the factory, because even a slight weakness can cause a huge accident in the middle of the sea. A huge bridge crane lifts steel bars, weighing several tons into the first stage of production. The entire factory shakes as the cutting process begins. An automatic bandsaw machine cuts each bar to a specific length using cold cutting technology. The measurements are so precise that even a millimeter of error is unacceptable. Each cut piece is called an ingot. It weighs more than 100 kilograms. Each of these ingots will be used to make a link in a huge chain. The ingots then go through a roller line to an induction furnace. Here, heat is not generated by ordinary fire. Rather, the temperature of the steel reaches about 1,600 degrees Fahrenheit in a few seconds through a huge electromagnetic field. As it heats up, the color of the steel gradually changes from dark red to bright orange, like a piece of molten lava. Due to so much heat, the metal then becomes flexible and is ready to withstand enormous pressure. Pressing begins immediately after leaving the furnace. The huge hydraulic press first slowly bends the ingot into a crescent shape. Each press of the entire machine is so powerful that the solid steel changes shape in a matter of seconds. Then a skilled operator inserts the red-hot link into the previously made link. This entire process has to be done in a matter of seconds, because once the metal cools, it is no longer easy to bend. Then, in the next step of the press, hundreds of tons of pressure are applied to press the two ends together. In an instant, a complete chain link is formed. But the work is not over here, because simply pressing the link together is not strong enough. Now comes the most important step: resistance butt welding. Here, the hot link is held tightly with a huge copper electrode, and high voltage electricity is passed through it. Due to the resistance of the steel, so much heat is generated that the two ends of the metal melt and fuse together forever. At that moment, the link is no longer two pieces. Instead, it becomes a single, continuous metal ring. The greatest pressure will be exerted on this joint in the future, so there is no room for error here. After welding, a little excess metal accumulates in the joint. It is sent to a special trimming press and cut perfectly. Then, the entire link is smoothed with a high-speed grinder, so that there is no friction or weakness in the future. While the links are being made one after another, the studs are being made on the sidelines. This stud is the strong support bar in the middle of each link. Although it seems small from the outside, a large part of the strength of the entire chain depends on this stud. Because during the intense tension and twisting of the sea, the studs protect the links from bending or deforming. The raw material heated in the furnace takes the shape of the studs in a few seconds, under the pressure of a huge press. Hundreds of studs are made per hour, and are stored in large containers. On the other hand, the links that are made are still red hot. The operator first inserts the cold stud between the links. Then, as the hot link cools and contracts, the studs are firmly stuck, as if the metal is locked inside the metal. Then a skilled welder makes small but very important welding on both sides of the stud, so that the stud cannot move even a hair under the pressure of thousands of tons of sea. Even though the chain link is finished, the entire system is still not complete, because one of the most important parts is still missing. The shackle. This shackle is what holds the anchor and the chain together, so it has to be several times stronger than a normal link. It starts with a huge carbon steel block weighing 265 pounds. It takes more than 15 minutes to cut this block with a huge cutting machine. Then the blocks are heated in a huge furnace for several hours at a temperature of 2,200 Fahrenheit. Gradually, the metal becomes bright like a burning fire. Then that hot metal is taken to a gigantic 6,000-ton press. In a few seconds, the metal is pressed into 2 wide ears and a thick, strong body. Then it is heated again in the furnace, because the hotter the metal, the more precisely it can be shaped. Then a huge hydraulic bender slowly bends the shackle into an arch shape. In this entire process, every angle is measured with a computer-controlled sensor, because even a slight unevenness can weaken the entire shackle in the future. Before it cools, the shackle is inserted back into the mold of the forging press. Due to the intense pressure, the hot steel fills every corner of the mold, creating a perfect shackle body. After cutting off the excess metal, a long grinding process begins. The entire body is made so smooth that there is not a single rough part anywhere. Now the shackle pin and nut will be made. The pin is made from an ingot weighing 130 pounds. First, it is heated and pressed into a huge hexagonal head. Then a CNC machine cuts the thread with micron-level precision, so that not a single millimeter is left blank when the nut is installed. But strength does not come only in size. Real strength comes from the internal structure of the metal. So begins the most important of the 3 stages: heat treatment. Heating, quenching, and tempering. First, the metal is heated to a high temperature. Then it is quickly cooled by dipping it in cold oil for a moment. Then it is heated again to a specific temperature and prepared in such a way that it is extremely hard and flexible at the same time. As a result, it does not break even under extreme pressure. Once everything is ready, the most terrible test begins, because there is no forgiveness for mistakes in the sea. First, a magnetic particle test is carried out. This test detects even the smallest hair-like cracks. Even if it looks perfect from the outside, if there is a slight weakness inside, it can also be detected. Then comes load testing. A huge hydraulic machine applies a force of up to 2,400 tons and pulls the entire chain. Every link, every weld, and every shackle is tested. If there is even the slightest deformation, the entire part is rejected. Once the test is passed, the entire chain is smoothed again with a grinder. Then it is cleaned and sent to a 10-meter deep asphalt coating pool. This special coating protects the chain from salt water, cold temperatures, and long-term rust. When the coating dries, the entire chain looks like a huge black monster. Finally, each section is stamped with a serial number, so that it can be tracked from any port in the world in the future. Then a huge crane lifts separates the chain sections weighing several tons and loads them into containers and sends them to the port. From there, their real life begins. On the deck of a huge cargo ship, severe storms at sea, hundreds of feet high waves, deep currents, and thousands of tons of tension. This chain will fight against everything every day. It will hold hundreds of tons of anchors on the seabed and keep billions of dollars of cargo, huge ships, and countless lives safe. Just think, these iron links, starting from a simple steel bar, are one of the foundations of trade, security, and navigation in the modern world today. When a huge ship anchors in the depths of the sea and stands still, the real work of this invisible iron monster begins. Be it the pressure of thousands of tons, the fiercest storms, the currents of the dark night, or the merciless power of the ocean. No matter what comes, these chains never give up easily. Because they are not just made of steel, they are made of a remarkable combination of fire, science, power, and perfect engineering.